Hello, everyone. Today, I would like to present the importance of permutation importance concept in machine learning, and these are a series of SolX education videos. I am Himan Namdari. I'm a PhD student at Data Science Department at Worcester Polytechnic Institute. So, as you know, understanding the significance of features often will play a great deal in machine learning and interpreting the models. Today, we dive into permutation importance, a powerful tool that shines a light on which features truly drive prediction. So the concept behind permutation importance is that let's have an example of a time series data that you have a vector of features and you would like to predict a value. In this case, you need to know which of these features are the most critical for your prediction performance in general. So we basically, what is happening, unlike the traditional statistical method, the permutation importance is having a dynamic perspective, reshuffling the features value to unveil their impact on the model accuracy. And now today we want to dive in and realize how we can do this. And this will show us, it's going to be our guidance in the decision-making, in the process realm of data science in general. So let's dive in. So to define permutation importance is a technique that will be used to assess the importance of the features in your machine learning model. And let's stick to one example. Let's say we have a house price sort of like prediction concept, and we have like 20 features, including the number of rooms, the distance to the police station, to distance to school, number of bedrooms, and so far, so on. Among these features, there are features that are going to be more correlated to the predicted value for the price. Therefore, we would like to find those values. So the purpose behind it is basically to identify which features have the most significant impact on the model performance. So there are some steps to process the permutation importance, and we're going to go over them one by one in more detail, but overall we have almost 7 steps, and the eighth step is going to give us the rank features. Step 1 will be training a model. Due to evaluation process, we need the metrics and we need to calculate a baseline model. We do the feature importance assessment. We measure the impact, and then we calculate the importance based on the quality of that model. And we'll repeat this for all features that we have. And at the end, the permutation importance will give you a vector of feature importance of your features that has been processed. So for training the model, we can use different type of regression models. Bear in mind that permutation importance commonly works with models that they have one label. As for the target value, same for the price of the house, we just have one value that we would like to predict, and that's the price of the house. So commonly, permutation importance can be used for target values or models that are trying to predict one value. We can use linear regression or random forest as our base model. And then we basically run the model and we get an root mean square error respecting, depending on the metrics that you're selecting, but commonly we can use root mean square error. So the training model is basically give us a baseline saying that having all of the features that exist in the model, linear regression or random forest model can obtain a specific amount of root mean square error. So to select a metric, again, it's going to affect your quality. It's going to make your importance vector a little bit skewed, but make sure that you're selecting correct metrics for your model, because we are using the metrics to evaluate the performance of the permutation. We did calculate and talked about the baseline. We are not changing anything in our data set or our feature set. We are basically feeding the original and unaltered data set into our model. And this will establish a baseline. Feature importance assessment in section 4, the selected features whose importance you want to evaluate will be randomly shuffled. And while we don't have these values in our data set, we will basically perform another training and we calculate the root mean square and we compare it to our baseline. So basically, we are trying to measure the impact of not having some of these features in our data set, and the one that are altering or changing the root mean square more and making more worse basically have less information, and the ones who are impacting the root mean square the most will have the most information. So basically, whenever we see the root mean square in our feature example, with compared to the baseline, is getting more, we know that this impact of this specific features that was shuffled and removed from the data set has more specification for the model. So we compared the new performance metrics with the baseline metrics, as I mentioned before, and the difference between the new metrics and the baseline metrics reflects the impact of the shuffling the selected feature. We basically iterate through all of the features that we have from step 4 to 6, and then we evaluate the impact of shuffling of each features on the model performance. So this will show us, by not having one of the features, what will happen to our root mean square error value. There are some advantages of permutation importance. It's a model agnostic method, so it's suitable for any model. Linear regression to deep learning doesn't matter. It's an intuitive approach because we just shuffle the features value and observe their effects on the model performance. It actually has a direct impact on performance because it shows how the model performance deteriorates when the feature is permuted. So this is like what we actually doing. And it also can capture the nonlinear relationship and kind of like interaction effect of some other method also will be considered while we're doing the experiment. There are some limitations, obviously, with this method. It's computationally expensive. When you have a large number of data, it's going to be challenging. There will be also some issue with correlated features. The reason is that it's going to make the feature importance bias if you have features that are correlated and having a high value for their correlation. And it's going to have the potential of misattribute the importance among correlated features. It's also metric dependent, so the importance might change based on the choice of evaluation metrics. So what you can do is maybe select several metrics and see which one of them are giving you the best result. There are also multiple runs needed for doing this experiment. But the conclusion over permutation importance is that basically it's a universally applicable, so you can work with any type of model. It's an insightful approach because it can capture both a linear and complex relationship. And you should also consider the correlation of your data, as I mentioned before, and it's computationally intensive, and it's dependent on your evaluation metrics. So this is what we want to know about permutation importance. Generally speaking, to remind you again, this is a method that can help you to find the highest values of importance in your feature data set, or in your feature set, let's call it. And the main idea behind it is basically to randomly shuffle the feature set and see the impact of that shuffled features on our baseline metrics, which is the using of all this feature set with respect to not having some of them. Thank you so much for listening. I hope this video can help you to understand permutation importance much better, and I'm hoping that you can use permutation importance in your machine learning model and get a better performance in your training. Thank you.